Okay, today in chemistry, we are going to start chapter 10, chemical quantities. You're going to need a calculator and you're going to need your periodic table. Before we get started, I want to tell you when we pull masses from the table, so the number at the bottom of each square is the mass of 1 mole of that element. I would like for you to pull the masses to the first decimal place rounded correctly. So for instance, lithium, so here's your first decimal place. You look immediately to the right one place. If this is 5 or above, you'll round that up. If it's not, you won't. So we would say lithium's mass is 6.9. Beryllium's would be 9.0. Potassium's is 39.09, so this is your first decimal place. Immediately to the right is a 9, so you're going to round that up to 1, so that'd be 39.1. Calcium would be 40.1. Scandium would be 45.0. All right? Okay, so the first thing we're going to do is talk about how you calculate molecular and formula mass. So once again, when using the periodic table, please use the mass to 1 decimal place rounded correctly. So molecular mass is the atomic masses of all the atoms in a molecule added up. And if you'll remember, a molecule involves 2 or more nonmetals or hydrogen and nonmetals. Your unit will be GMM, which stands for gram molecular mass. So here's our first example. Calculate the molecular mass of CH4. Okay, so here's how I'd like you to set them up. So you look at your formula, it tells you what you have. So you have 1 carbon. If you look at carbon's mass from the table to 1 decimal place, it's going to be 12.0. And then we have 4 hydrogens according to our formula, so 4H. Each hydrogen is 1, so that is 4.0. So the mass of CH4, which is methane, is 16.0 GMM. Okay? So methanol, so we have 1 carbon. We have a total of 4 hydrogens. We have 1 oxygen. Carbon, once again, is 12.0. Each hydrogen is 1.0, and oxygen is 16.0. That's 12.0. 4 for your hydrogens, 16. So when you add those up, that's going to give you, this would be 20, that would be 32.0 GMM. All right? Okay, formula mass. Formula mass you calculate in the same manner, but you just need to remember formula mass is if you have an ionic compound. So it is the atomic masses of all the atoms in an ionic compound added up. So once again, if it's ionic, we talked about this in an earlier chapter, that will involve a metal and a nonmetal, or a metal and a polyatomic ion. So if you remember, when you write formulas, you look at your charges. They have to equal 0. If they don't, you crisscross to balance. Your unit will be GFM, gram formula mass. So we are going to do it in the same manner. It's just a different unit. Okay, so calculate the formula mass of calcium nitrate. So you've got to write your formula first correctly. So you have calcium. Nitrate is a poly, NO3. This is a 2 plus, 1 minus, so we're going to crisscross. We're going to put this in 2. In parentheses with the 2 on the outside, excuse me. Anything in the parentheses, you're going to multiply by 2. So we're going to look up 1 calcium. We're going to have 2 nitrogens. And then 2 times 3 is 6. We're going to look up 6 oxygens. Okay, calcium, if you look to the table to 1 decimal place, rounded correctly, is 40.1. Nitrogen, each nitrogen is 14.0, and each oxygen is 16.0. So we're going to add up 40.1, 28, and 96. Okay? So most of the time your teacher will tell you how they want you to pull from the table. All right, so the formula mass of one formula unit of calcium nitrate would be 164.1 GFM, gram formula mass. Okay, so now if you want to put the video on pause for a second, you may have to write the formula on a couple of these, add up their mass. Okay, sodium chloride is NaCl, so you have 1 Na, 1 chlorine, sodium is 23.0, chlorine is 35.5, okay? Since it's just one, I'm just going to add them up. So that's going to be 68.5. This is ionic, so your unit is GFM. Sucrose, you have 12 carbons times 12. For each carbon is 144. You have 22 hydrogens. Each hydrogen is 1, so that's 22 more we're going to add to that. You have 11 oxygens. Each oxygen is 16, so 11 times 16, 176. So we're going to add these three up, 176 plus 22 plus 144. So this molecule will weigh 342 GMM. These are all, we've got carbon, oxygen, nonmetals, hydrogen, acts as a nonmetal. Okay, fluorine, please remember you have 7 elements. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. If they're by themselves, you would write them as diatomic, so this would be F2. So each fluorine is 19, so 19 times 2 is 38.0 GMM. Pretty simple. Okay, the next topic is relating mass to number of atoms. So we need to talk about what a mole is. A mole, you can write it as MOLE or just MOL. Please do not just use an M, that is mass. The mole is the SI unit. We mentioned this, I think, in Chapter 2, for the amount of a substance. Its definition is, it is defined as the amount of substance that contains as many particles as there are atoms in exactly 12 grams of carbon 12. It's a measuring unit, just like a dozen. So just like you can have 1 dozen, you can have 2 dozen, you can have a half a dozen, you can have 1 mole, 2 moles, a half a mole. Now, in a mole, there's a certain number of particles, and that is called Avogadro's constant or Avogadro's number. Constant because it never changes. So Avogadro's constant is the number of particles in a mole. 1 mole of a pure substance, so we're saying an element or a compound, will contain 6.02 times 10 to the 23rd particles. You can use Avogadro's number to count all kinds of representative particles. So 1 mole of sodium ions will contain 6.02 times 10 to the 23rd sodium ions. A mole of carbon's an element, so it's made up of atoms, so a mole of carbon contains 6.02 times 10 to the 23rd carbon atoms. Water is 2 nonmetals, so it makes a molecule. So 1 mole of water contains 6.02 times 10 to the 23rd water molecules. And then NaCl is ionic, so this would be a formula unit. So we say 1 mole of NaCl contains 6.02 times 10 to the 23rd formula units. Okay, so the point is a mole of anything would have Avogadro's number of particles in it. Then when you talk about a mole, you can also talk about what does it weigh. So that's called its molar mass. So the molar mass is the mass of 1 mole of a pure substance. Once again, a pure substance is either an element or compound. The unit is usually written as grams per mole. So when we did this on the front page, even though we said this was G per molecule or per formula unit, really that is what 1 mole of that compound would weigh. So boron, so if I said go into the lab and get me a mole of boron, so boron is 10.8, so that means you would go in there and you would put on a balance 10.8 grams, and that's what 1 mole of that would weigh. Mercury, Hg, is quite a bit heavier. 1 mole of mercury has a molar mass of 200.6 grams. Okay? So a molar mass of an element contains 1 mole of atoms. So 1 mole of boron, once again, is 10.8 grams. And in that 10.8 grams, there's Avogadro's number, which is 6.02 times 10 to the 23rd atoms of boron. Silver's mass is 107.9. So if I said go weigh me out a mole of silver, you would go in there and weigh out 107.9 grams. And then if you could count all those atoms, it would be 6.02 times 10 to the 23rd atoms. Obviously, you cannot count an atom. Okay? Okay, the next thing, molar mass. So this is per mole of an element. Molar mass is, once again, what we kind of calculated on the page before. Molar mass of a compound is calculated by summing the masses of the elements present in a mole of molecules or formula units that make up that compound. So here's a couple of scenarios. So it says how many moles of atoms of each element are found in 1 mole of each of the following. So you look at the formula. So Al2S3 has 2 moles of Al, and it has 3 moles of sulfur. If you look up aluminum's mass on the table, it is 27.0. So that's going to be 2 times 27 is 54. Sulfur's is 32.1, and we have 3 moles of that, so that is going to be 96.3. And you add those two up. One mole should, hopefully if I've added that up right, should be 150.3 grams per mole. Okay. Barium hydroxide, so we're going to look up 1 barium. Remember, anything in the parentheses is multiplied by the number outside, so we're going to look up 2 oxygens and 2 hydrogens. Barium is 137.3. 2 oxygens. I think I'm just going to make it simpler. Each oxygen is 16, so that's 32.0. And then each hydrogen is 1, so that's 2 more. So when we add those up, 137.3 plus 32 plus 2. So 1 mole of barium hydroxide should weigh 171.3 grams. So if I said go get me a bowl of barium hydroxide, you would mass out 171.3. All right, so the first thing we want to do is we're going to learn how to calculate going from grams to moles, moles to grams. All right? Okay, so it says how many grams of helium are in 2 moles helium. So what you do is you always write down the thing with the number first. So you have 2 moles helium times division bar. Now, like this is over 1, so mole of helium is in the numerator. So to cancel it out, we're going to put it in the denominator. So you're going to say mole helium, gram helium. So you just need to remember, if you're looking something up on the table, that is per 1 mole. So this is 1 mole. Helium's mass is, so over here it's cut off, 4.0. So 2 times 4 is 8. 2 times 4 is 8 grams helium. This number here is what you're going to look at for your sig figs. 2 only has 1, so you'll write your answer as 8. So if I say go get me 2 moles of helium, if you could, then you would go in there and mass out 8 grams. Obviously, helium's a gas. Okay, the next one. What is the mass in grams of 3.5 moles copper 2 chloride? So we have 3.5 moles. CuCl2, so everything needs to have a unit, times 1 mole CuCl2. So we're going to go to the table. We're going to look up 1 copper. We're going to look up 2 chlorines. So copper's mass is 63.5, and chlorines are each 35.5. So 63.5 plus 71 for your 2 chlorines. So 1 mole of copper 2 chloride would have a mass of 134.5 grams. Okay? Mole of CuCl2 will cancel. I should have canceled that. You multiply across the top, divide by what's on the bottom. So 3.5 times 134.5 will give you 470.75. but this only has 2 sig figs, so we're gonna write this as 470 grams CuCl2. Okay? So if you'd like to put me on pause for a second and you work the next two. Okay, so 2.25 moles iron times, in every 1 mole iron, there are 55.8 grams. So we're going to take 2.25 times 55.8. That's going to give us 125.55. We want 3 sig figs, so we're going to say 126 grams iron, rounded correctly. Mole cancels. Okay, you have 0.375 moles calcium hydroxide. Okay. Whoops, forgot mole. Okay. So in every 1 mole calcium hydroxide, we want to figure out our grams, so we're going to look up 1 calcium. We're going to look up 2 oxygens and 2 hydrogens. Calcium is 40.1, plus the 2 oxygens are 32, plus your 2 hydrogens are 2, should be 74.1 grams. We're going to multiply that times 0.375, and then divide by 1, which is the same thing. We want 3 sig figs, so we're going to say 27.8 grams calcium hydroxide. Okay? Okay, the next one, now you're starting with grams and you're going to go to moles, so we're going to say 11.9 grams of aluminum times division bar. You want to get rid of grams, so grams is now going to go on the bottom, and you're going to moles, so mole goes on the top. So remember, when you look up something from the table, that is in 1 mole. So you look up aluminum, aluminum is 27 grams. You're going to multiply across the top, divide by what's on the bottom. So 11.9 times 1 is the same thing, divided by 27. We want our answer in 3 sig figs, rounded correctly, so we're going to say 0.441 mole aluminum. Okay? Grams AL cancels. You end up with mole. Okay, the next one, you have 5 grams calcium chloride. And you want to know how many moles that is. So grams calcium chloride goes on the bottom. Mole calcium chloride goes on top. So we're going to look up calcium, which is 40.1, plus 2 chlorines are 71 total. So 1 mole of calcium chloride weighs 111.1 grams. Grams calcium chloride cancel. We're going to multiply across the top. 5 times 1 is 5, divided by 111.1. Okay, so we want our answer in 3 sig figs. 5.00 has 3, so we're going to say 0.0450. This 0 in front is not significant. If it confuses you, just hit second 5, and it will put it in scientific notation. Now it's easy to see. You would write this. You could also write this as 4.50 times 10 to the minus second mole. Okay. All right. Okay, now if you want to put the video on pause. Okay. So now you have 3.60 times 10 to the minus 10th grams gold, and you want to know how many moles it is. So we're going to put grams gold on the bottom and 1 mole gold on top. We're going to look up gold's mass, 197.0. So we're going to take 3.6 EE10 negative times 1 and then divide by 197. And we want this in 3 sig figs, so we're going to say 1.83 times 10 to the minus 12 moles gold. Grams gold cancels. Okay, 26 grams bromine. So remember, bromine is one of your 7, but the formula even tells you that. So we're going to go grams bromine on the bottom and 1 mole bromine on top. So we're going to look up bromine's mass, 79.9, and we're going to multiply it times 2. 159.8. Okay, so we're gonna take 26, divide it by 159.8 equals, and so 26 grams of bromine would be the same as saying you have 0.16 moles bromine. Okay? Okay, so that is going to be it for this video, and that will cover homework set 1A on chapter 10. Thank you.